Well, students, welcome back once again to MECH 2320. We're going to be talking about DC motors, which means that we will have simply DC power supplies, either fixed or variable. But one of the first things that we need to address is modeling the motor electrically. So what we will start out with is a simple model of an electrical wire in a DC circuit. So what we'll have to account for is the resistance, the DC resistance of the wire, and for any coils or coiled wire that has been put into that shape for the purpose of creating magnetic fields. Why? Because the magnetic field is the field force that gives us the strength, the torque, and the speed of the motors. So we have to be able to explain it. We need to be able to understand. What we'll do to simplify things is we will address the shunt connected DC motor. The shunt connected motor has essentially two field generators on the stator, and the stator is the part of the motor that does not rotate. Okay, it's part of the outer shell of the motor, and the other field winding is the armature, okay, which is on the rotor, which we connect electrically by using a commutator with brushes. So let's take a look at the shunt winding. Okay, now there's some videos that are available to this class that will show you where these windings are found. But the shunt winding has no moving parts, so it's purely electrical. It produces a very strong magnetic field with a very small amount of current. Now, how do we do that? We simply make sure that the inductance of the shunt winding is quite large. Okay, so let's take a look at the model of the wire, okay, for the shunt winding. So we'll start here. We'll call this one let's call this one connection F1, and we'll connect it right here. And we'll begin our wire. Now, all wire has electrical resistance, okay, depending upon the size, depending upon the length of the wire and the diameter, okay, those two parameters determine what that resistance will be. So let's model the wire as having a resistance, and it has a coil. Okay, now we have lumped the resistance of the wire. It is not lumped, okay, but we can model it that way as resistance R. The coil, we can give it a name if we wish. Okay, it does have an iron core. We'll call it, let's call it the shunt field winding. there you go. This is the shunt field winding copper wire. It has some resistance, which is measurable, and we can experimentally determine what the inductance of the shunt field winding is. Okay, and by the inductance we can tell whether it's going to create a strong magnetic field or a weak magnetic field. So we'll call it shunt field winding, and we'll use L because it is an inductor, but it is used in a DC circuit, so we'll see no reactance out of it. But this is basically our model. If I take an ohm meter and measure it from F1 to F2, I will measure that resistance R. We will see no effect on the ohm meter reading by the inductance of the winding. Typically for the motor that we have in our lab here, this resistance is about, I'll say about 3,000 ohms. Now let's take a look at the rotor. The rotor means that it does rotate. Start on the left again. That's A1 terminal for armature 1. Okay, and we'll have resistance of this circuit. Ooh, that's not a resistance, is it? How about if we take a look at the resistor? Okay, and this wire is formed into a coil, so we'll represent it again as an inductor with an iron core. And then we get to the armature. Okay, the armature is the rotating piece of the motor. It has brushes. There's a brush. There is a brush. And we have the terminal A2 that goes with that. Excuse me, again, that seemed to be sloppy. There's the model for the armature circuit. It is the electrical model for the armature circuit. It can be more complex, but this works for us, so we'll use it. Now then, I've said we're going to address the shunt configured DC motor, and that's what we're going to do. But the motor that we're going to be looking at carries a third winding, which is the series winding. It is a low resistance, high current winding that is put in series with the armature circuit when you decide to use it. Okay, you don't always use the series winding, and there will be times, I think they'll be rare, where you won't use the shunt winding. Okay. The model for the series winding looks exactly like the shunt winding, with the exception that the size of the coil, the size of the wire, and therefore the resistance will be radically different than the shunt values. So, here you have it. This is the model of the 3 circuits that we find in a compound possibility motor. Okay, we're going to start out talking about the shunt winding, and we're going to talk about the armature circuit. We'll always talk about the armature circuit. If we don't have an armature with a motor, I'm not sure that there would be any value for the motor, right? Normally we're trying to rotate something so that we can control the motion of a machine. Okay, so we have the shunt winding electrical circuit, series winding electrical circuit, and the armature winding electrical circuit.